Hey everyone, thanks for tuning in again. And today I'm going to give you a walkthrough of my NSX-T Homelab environment. In my last video I explained how I set up a fully nested Homelab environment running on a single ESXi host. Today I'm going to dive into NSX-T and how you need to set up all the profiles, the edge node, etc. to get a fully functional BGP routed topology with logical networking inside of NSX. Really cool stuff. Can be quite complex if you're new to NSX-T and networking. Yeah, but let's get to it. So before we dive into the lab environment itself, let me switch to a diagram I created. Yeah, to give you an understanding of where we are in the topology. So you're looking at a single ESXi host. And that single ESXi host, that's a nested host running as a virtual machine on my physical server. The benefit of that is that I can create additional NICs very easily. So with NSX-T, it's really handy if you have 4 physical NICs to use, because you can dedicate 2 NICs to your normal VDS for vSphere networking, your normal port groups, your VM kernel ports, and then you have 2 NICs to spare, which you can dedicate to NSX-T and the NVDS. Yeah, so it's a nested environment, so it's just a matter of configuring the virtual machine with 4 NICs, and we're good to go. So if you take a look at this diagram, you see that I have a VDS environment with 2 uplinks, so 2 physical NICs. This is just vSphere networking. So I have VLAN 10 on a port group configured with a VM kernel port for management. I have VLAN 6 configured, which is the TAP overlay port group. VLAN 11 is used as an uplink VLAN between my edge node and the T0 router running on top of it, and my physical router, which is the VMware appliance. I have VLAN 8 configured for vSAN and VLAN 4 configured for vMotion. This is just basic vSphere networking again. So to do NSX-T networking properly, you need and to do north-south routing, we need an edge node, of course, with routing services. That edge node is running as a virtual machine, so it's a VM form factor. It's running on top of ESXi. It comes with 4 physical or with 4 network interfaces. ETH0 is used for management, so this is connected to my VLAN 10 for management. FP ETH0 is used, it's mapped to my NVDS for tap traffic. VMNIC 3, which is called internally FP ETH1, is used connected to my VLAN NVDS. So that's this one. And VNIC 4, which is FP ETH2, that's actually unused in my Homelab environment. As a best practice, you always would like to have redundancy in your routing. So normally you would hook it up to a second uplink, which goes to another physical router. But in my Homelab environment, I want to keep an eye on the resources I use. So I just use a single uplink. So let's take a look at what that looks like in my lab environment. So the first thing you need to configure, if you're configuring the fabric for NSX, is a transport zone. The transport zone is not on my diagram, but it's really simple. You need 2 transport zones. One for overlay traffic, so for Geneva traffic, and all the logical segments that you will create in NSX, and you need a VLAN uplink, a VLAN transport zone. This one is only used to define the boundary of where your routing can go, of where your switching can go. So any segment you create in NSX-T, it cannot go out of your transport zone. So it's not a security setting or a security measure. It's basically an administrative boundary that you set. And you need an overlay transport zone and an uplink transport zone. That's it. You need to configure those, really easy. Next up is creating an uplink, an edge uplink profile. Because if you go back to the diagram that I just showed, how do we know how the NICs on the edge, how they map on the uplink? So that's that's a question. And that's where an edge uplink profile comes in play. So if we zoom in a bit, so looking at this mapping, so how do we map FP-ETH1 onto VLAN 11? That's done by a combination of the edge uplink profile and the edge transport node profile. So we start with the edge uplink profile. And all we do there is define the uplinks. So you can define an active uplink and standby uplink. Well, actually, in a VM-based edge node, you can also deploy an edge node on a physical box. If you do a virtual machine form factor, you can only have a single uplink. So I'm defining a single uplink in my edge uplink profile. The second thing we do, if we look at the edge transport node, this is where we map the uplink I just defined. So this is uplink 1, which I defined in the edge uplink profile. Here I really map it onto a physical and onto a specific NIC of the edge node. So as you recall, FP-ETH0, that's mapped. FP-ETH0, that's mapped to my NVDS for tap traffic. So that's what we use on the. That's what we use for the overlay. So we create an NVDS overlay, which is this one. It's called NVDS1 in my diagram, but it's actually in my Homelab. It's called NVDS-overlay. NVDS overlay. I define the edge uplink profile and I connect the uplink defined in the uplink profile to the virtual NIC. Now, we do the same for the NVDS, and as you can, I forgot to mention, here you can see the transport zone. So this is within the overlay transport zone, and we have a second NVDS configured for VLAN traffic. So the transport zone here is the VLAN uplink transport zone. Again, I use the edge uplink profile, and the uplink is now mapped to FP-ETH1, which is the second NIC. And if we go back to the diagram, that is FP-ETH1 that's being mapped onto the NVDS2 in my diagram, and that in the backend is mapped to VLAN 11. Now, how is that mapped to VLAN 11? That's done by defining a port group on your NVDS with VLAN 11. So the tagging takes place here. Here we define VLAN tagging. Now we have the need to switch back. Now that we have the edge transport zone transport node configured, we have two NVDSs, one for tap traffic, one for VLAN traffic. It's all being mapped. Next up is configuring the host uplink profile, because hosts also have a uplink profile. As you can see here, I have an uplink profile configured with two uplinks, uplink 1, uplink 2, active and standby. I'm doing tagging here, so I'm putting it on transport VLAN 6, and if we go back to my diagram, here you can see the NVDS that I'm configuring for overlay traffic. It has two uplinks, and one is active and one is standby. So uplink 1, uplink 2. Now, how do uplink 1 and 2 get mapped onto the physical NIC, so VMNIC 2 and VMNIC 3? Yeah, you've guessed it. It's done in a transport node profile. So let me go back to NSX-T. Here you can see the NSX node profile. It's really similar to what we configured for the edge transport node. Now we define NVDS1 is the name of the switch. It's an NVDS type. It's overlay traffic, so it's in the transport zone TZ overlay. I'm not using network I/O control. Here I define the host uplink profile. I use an IP pool to assign IP addresses to the TAP interfaces, which do the encapsulation and de-encapsulation of the Geneva overlay traffic. And here you can see the active uplink is mapped to VMNIC 2 and the standby uplink is mapped to VMNIC 3. Now the settings down below are used if you only have two NICs to your disposal and you need to consolidate all your traditional port groups and your TAP interfaces onto a single NVDS or a single switch. I'm not using that because I have 4 NICs in my Homelab environment. But here you can see that we're using the transport node profile to prepare the ESXi host for NSX and the creation of the TAP interfaces. Now, how can we test if all the TAP interfaces can connect to each other? Well, we can connect onto an ESXi host, and we can do a VM kernel ping using the VXLAN net stack. Well, this is a bit confusing because we're actually not using VXLAN. We're using Geneva as overlay traffic, but the net stack is still called VXLAN on the ESXi. I'm defining a size of 1572 bytes, so we can test if all the MTU sizes are correct end-to-end between all the interfaces. So let me ping my edge node 10.06.10. So that's working. So this is traversing VLAN 6. This is my edge node. This is my ESXi 1 host, number 2, and number 3. Well, this shows me that my TAP configuration is correct and my data plane is up and running. Now, with the edge configured, we can create an edge cluster and put the edge node in there. It's just a matter of clicking this right arrow and putting the edge node into the edge cluster. Now, with that, we can create our segments, a tier 1 gateway and a tier 0 gateway. In the topology, a tier 0 gateway connects to your physical network. A tier 1 gateway is used for for connecting all the segments. So let's show you how to configure your T0 router. So I'm defining a T0 router. I'm using an active standby mode for HA, so I'm not doing active with load balancing or anything fancy like that. So here is where I create the uplink interface. So this is the interface that connects to my VMware router over VLAN 11. So it's connected to this segment, VLAN uplink, which I will show in a minute. It's running on the edge node, of course. We only have one. I define the MTU size of 1600 to make it consistent. And we're doing routing over that segment. Before I show you that, let me first log on to my my VMware router and show you VLAN 11 with the IP address, and I can ping 172.27.11.2, which is my T0 router. Connectivity is up. So I'm connected and I can do BGP routing between my T0 router and my VMware appliance. I'm defining a local autonomous system number. I'm setting BGP to on. I'm leaving everything to default, to be honest. And I then configure a BGP neighbor. My neighbor is the VMware router, which has .1 as the IP address. The remote AS number is the autonomous system number on the other side. So if I zoom in on my config, you can see that my protocol BGP is configured like this. So the local AS is 65.001. So this is the remote number from the T0 perspective. And that's it. I'm defining this host as the source address. Timers and passwords are all default. Didn't change them. And then on the other side, on the VMware router, this is basically the configuration. So this is the local AS number. I'm defining the neighbor, defining the remote AS number. So this is the 65003, which was configured as the local AS on the T0. I configured the timers and I configured the router ID. And that's it for BGP routing. Here you can see that the BGP neighbor relationship is successful, so it's established. You can also look at that from a VMware show IP BGP neighbors. Here you can see that it is established. So this is the BGP state you're looking for. If it's active or idle or whatever, then there's something wrong with your configuration. The BGP state needs to be established before it will exchange routes. So which routes have I learned? These are the BGP learned routes. So I have 3 segments configured in NSX-T, which we will go over in a minute. And I have a BGP peering or a network learned as the uplink. This is the uplink network. So how did it learn these routes? Let me dive into route redistribution. I'm basically telling NSX-T to do route redistribution. And what is it redistributing? All the static routes that I configured on the T0, connected interfaces, and I redistribute routes from all the T1 subnets which are connected and define a static route. So what does that look like on the T1 router? The T1 router is of course connected to my T0 router, which is an internal link. I have 3 segments linked, which are my web, database and app segments. So these are the segments that hold my virtual machines. And routing is being advertised. Let Let me go to edit mode. Route advertise is all connected because these are the connected networks to my T1s. So I have a number of segments, so 3 segments connected to a T0 router. These routes get distributed to my T0 router, and the T0 router advertises them to the physical world. So if I go to my physical environment, I can do a ping 150, for example. I think this is up and running, and then you can see that it's traversing my network. That 150. It's hitting my default gateway, which is my ISP router. I have a static route configured for the 10th segment there, so it gets forwarded to my VMware router. The VMware router sends the traffic to the T0 router. This is the internal link between the T0 and the T1, and then in the end I get to my virtual machine. So yeah, that's it. If we switch back to the diagram once again to do a short recap. So I have edge node configured with 4 NICs, uplink profiles for the edges, and the transport node profiles. Kind of map all the things together to make sure that the interfaces get connected to the right port groups on the right VLANs. I have a standard vSphere distributed switch with 2 uplinks connected to my physical NICs. I have an NVDS configured in NSX-T with an active uplink and a standby uplink, which get mapped to VMNIC2 and VMNIC3 as an active and a standby interface using the transport node profile and the host uplink profile. Yeah, T0 routing, T1 routing, everything's in place. So yeah, this video was a bit longer than I expected. Hopefully it's useful. There's a lot more to NSX that I can spend time on. This is really just the basics, getting the data plane in place, so the fabric, and getting the north-south routing via the T0 and the T1 in place using BGP. Yeah, lots of fun. So this is it. Enjoy, and make sure to subscribe to my channel. I will hopefully do a lot more of these kinds of videos. If you have any questions, hit me up on Twitter. It's the best place to find me. And see you next time. Thanks.